All right, we are recording. All right, today's TEC webinar is HVAC updates. There are at least 4 major things going on that we want to update you on. It's going to be like drinking from a fire hose. There's tons of stuff happening. We're going to try to really focus on the stuff that's happening in the next couple months, and then a little tiny bit of what's happening in the next couple years. And then maybe we'll just scare you to death with stuff that's happening in the future as well. You can ask me questions as we go. I'm going to try my best to monitor the question box. So I may or may not get there quickly, but I will get there. If you need, my screen not clicking. Oh, there we go. If you need PDHs for this webinar, you do have to answer the quiz questions. There are 6 quiz questions. You need to get 4 of them right. 2 of them have no right and wrong answer. So that means you only really got to get 2 other ones right. It's like getting your name right and you're already halfway there kind of thing. So if you need PDHs for Illinois and Wisconsin, make sure you answer the poll questions and answer them correctly. Everybody else is welcome to answer the poll questions, but you don't have to. So here's our agenda. First off, we're going to hit the refrigerant changes. So someone actually typed a question in already. The chat is disabled, correct? And the question and answer section is open. I find those 2 things to be extremely redundant in Zoom, so I disabled one of them. So yes, if you have a question, type it in the question and answer drop down, and I will pay attention to those there. Plus, it's one less screen for me to try to watch on all these screens. If I only have to watch 1 chat box instead of 2. So refrigerant changes, equipment efficiency changes, code changes, tax credits, existing and new, and utility rebates, existing and new. So it's like 4 hours of stuff that we're going to get it done in like 58 minutes or 68 minutes if it takes me that long. All right. So here we go. So very first start, quiz question number 1. Remember, if you need PDHs, you have to answer these. So I'm launching that question. Do you need a PDH certificate? There's no right and wrong answer unless you, of course, want a certificate. Then you have to answer that one correctly. So I'm going to leave this open for like 30 seconds. So this is a softball one, and question number 6 is a softball one, just to make sure you make it all the way to the end so I can properly give you your credits. All right, everybody has answered. I'm ending that poll. And actually 57% of you need certificates, right? So we'll get that taken care of. It'll take probably like a week because there's like well over 150 people on here. And probably a few that'll come in late because there's like 200 some registered. So it'll take a little bit for me to grade those and get those processed. So just be patient. Don't start hitting me up with emails on where it's at until like at least a week, and then we'll get you the certificate. All right. You guys should see my screen again. All right. So that's quiz question number 1, and we can go ahead and start. Refrigerant changes. All right. So some stuff's already happened, as you probably know. We had R22 done over with, other than, refurbishing it essentially. 123 is done for new equipment. That already happened. And then this year, we had our first production cap on all the HFCs, which includes popular 410A and 134A. So that means the manufacturers that refrigerant, instead of making 100% of what they made in 2021, they can only make 90% of that. And it's not equal. Some manufacturers get bigger caps than others because of who knows what. So that causes the price to go up a little bit. You might not have felt that because prices of everything were going up anyway. So it might have just kind of rolled into the, post-COVID pricing pain. But that happened at the beginning of this year. The next thing that's going to happen for refrigerant is the end of next year. So that is 15 months from now. You're going to start seeing HFCs ending for new chillers. So not existing chillers that you already have in the field, but new ones that you're installing. It's going to be significantly harder for you to get an HFC chiller. That is not a national thing currently. There are 18 states that it was supposed to be national, and then it got put on pause. And 18 states went ahead and adopted it anyway, and it might come back to being a national thing again here shortly. But officially right now, it's just 18 states. But if the manufacturers of chillers have to do something for 18 states, they're just going to do it for everybody, right? Especially when it's a lot of the bigger states. So expect your availability of purchasing refrigerants for the current chillers to be minimized, and in a year and a half you'll be buying, or less than a year and a half, you'll be buying new refrigerant chillers, which we'll talk about here too. And then like literally the day after that, the HFC production cap goes down 40%. So from 100 down to only being able to do 90, then only 60% of what they made in 2021 will they be able to make in 2024. That'll cause additional pricing pressure on the current refrigerants, driving people to more likely select a new refrigerant. And we'll talk about what those refrigerant choices are here shortly. And then at the end of that year, for a lot of other equipment besides chillers, many states are phasing out 410A on that. So that'll put pressure on the manufacturers to release newer refrigerant machines, because if you have to do it for a bunch of states, you might as well do it for everybody, kind of thing. And then we got a little bit of relief, a little bit of time where there's no changes. Another 5 years later, the refrigerant caps will drop again. 123 from a refrigerant standpoint goes away, right? It already went away for equipment a couple of years ago, but then 10 years after that, it goes away for equipment. And then way out in the future, we get some real pain on the current refrigerants being pretty much not available. It doesn't actually go down fully to 100% reduction or 0% allowed. It never gets that far down. So there'll always be, at least on the current law, there'll always be some availability of 410A and 134A and all the other HFCs, but it'll be pretty minimal availability and hence really, expensive. So what we're focusing on right now really is these three things that are happening right now for both chillers and regular equipment, that the availability of the current refrigerants from an equipment standpoint and a refrigerant standpoint is diminishing, hence new refrigerants, right? That's what we're focusing on at the moment. This just gives you kind of the details on the chiller timeline. Most of what you guys care about would be machines that are making 44-degree water. So the limit there is 750 for the GWP. That's what's imposing all of this, right? The standards that have been adopted for maximum GWP. We had the ozone depletion thing years ago, and we got all our refrigerants cleaned up on that. And now we're going to the global warming potential problem with refrigerants and trying to reduce and or solve that. If you have other machines that operate at different temperatures, which is not most of you, then there are different limits involved in that. But here's the one that applies to comfort cooling, 750. So that's the nugget right now. As far as the HFC reduction, HFC once again is 134A, 410A, and all that stuff. We already hit the 90% reduction, right? And then you see we drop down to 60, and then 30, and then it just continues on until we get to 85, and then we're on cruise control. So the next big nugget happens here at the start of 2024. All right, so the EPA, through the SNAP program, has already identified refrigerants that are approved alternatives to HFCs. That doesn't mean they're direct drop-ins by any means. It just means that they are suitable and allowed to be used. And the manufacturers will have to design their equipment to accommodate those because their current equipment probably can't handle it. So these are ones that have already been approved. We'll kind of go through each of these ones on here in a second. But those ones are pre-approved on the list. If somebody wants to get something else approved, they'd have to obviously appeal that to the EPA. So basically for manufacturers, this is their shopping list of refrigerants that they're probably going to be selecting from for the light commercial and residential market. And then if you got big stuff, big centrifugal chillers, you have other choices available to you as well. So when we look at those choices as compared to 410A, let me see if this got so many things on my screen. Get the highlighter thing going. All right, so our current 410A is this first column here. We've got the global warming potential, we have the capacity ability, we have the efficiency, COP, glide, etc. So right now, if you're looking at your various choices, you got to get under 750. So all 6 of these ones would do that. They're all under that amount. From a capacity standpoint, R32 looks pretty good. It's actually a boost in capacity, which is nice. The other ones have some penalties. Some minor penalties for 452B and 454B, some pretty bad penalties for these other 3, which is going to make them unlikely that anyone wants to use them for HVAC. Manufacturers want to use them. From an efficiency standpoint, 32, 452B, and 454B all get a little efficiency bump, but basically it's flat. And these other ones, even though they're badly penalized on capacity, they are a little bit more efficient, meaning they can hold a little more BTUs per pound ability, if you will. And then glide for R32 is non-existent. 452B and 454B is pretty minimal. And then it gets worse for these other ones. So you start looking at this, these last 3 on the right are probably ones no one's going to be selecting as a manufacturer because it's just too much capacity reduction and not even that advantageous on the glide. So they're pretty much shopping from these 3. And on the surface, R32 looks really nice. It's below the limit. You get extra capacity out of the deal, no glide issue, right? It looks really good. But as you're going to see, that 750 limit is actually going to go down again at some point, and that guy's not going to actually make it anymore. So then you might want to look at something else. So 454B is a very common choice that a lot of manufacturers are choosing because it's going to be usable now and 10 years from now. So we'll look at that. So that's kind of graphically, those drops that are happening in the global warming potential. So we got to be down below the 750. I know this slide says California. It's fairly old at this point, but there's 18 different states, not just California, that have this limit. So it's a lot of states, and it will probably be a national limit here based on some of the laws that have been signed recently. And then as you get further down into the future, 10 years out, some of these like R32 won't make the new limits that are expected then. So some manufacturers, R54B stays under that limit, at least in an extra several years. So you're going to see a lot of R32 equipment. You're going to see 454B, and you might even see some 452B. Although 452B doesn't really seem that advantageous. It's pretty similar. It's actually worse on global warming compared to 32. And you get a capacity penalty and you glide. So there's really no reason I would choose that one. It's like, if you care about right now, you'd pick 32. If you care about now and the future, you pick 454B. But 32 will be a common choice because it's very similar to what we're doing now with current refrigerants, and manufacturers that do stuff globally are very likely using 32 somewhere else in the world, and hence it makes it easier for them to import something for us in the United States. So 32 and 454B should be the two common choices that you see a lot of. All right, so in regards to those refrigerants, and pretty much all the refrigerants on that SNAP list, they do have a higher flammability than we are used to. We are used to, most of us, dealing with A1 refrigerants. So if you look at ASHRAE standard 34, which is one of two refrigerant standards for ASHRAE, 15 is the other standard. That's the safety protocols, like, scuba gear and all that stuff. But 34 defines all the refrigerants and assigns these R numbers, 454A, 454B. ASHRAE picks those numbers, and they go into these categories. So A means it's lower toxicity, B means it's higher toxicity, and then 1 means it is not capable of propagating a flame, 2 means it's flammable, 3 means it's highly flammable. Well, these refrigerants we're talking about do have a flammability component, so they can't be A1s like we're used to. Used to meaning all of our regular HFCs, like 134A and 410A, they're all A1s. So none of the new ones can be an A1. But A2 imposes many new rules and restrictions on what you'd be able to do. So several years ago, ASHRAE created a new category to squeeze it in between A1 and A2. So it's A2L, and then accordingly B2L if you have a higher toxicity. But A2L is what we're focused on. So it is technically flammable, but it is very difficult to ignite it. So it's not full flammable, but it's also not flammable, right? So we're in the middle there, and we'll kind of explain what that means with some examples here. So essentially, I forget whose study this was because I can't see this is AHRI. My note screen's on the other monitor. So it's AHRI's data showing you some of these different refrigerants. Here's these A2Ls in this baby yellow color, whatever that's supposed to be. So they're not full flammable, but they are in fact flammable. But they're very difficult to ignite. You need a pretty large ignition source. Like, you're not going to be able to light it with your Bic lighter. That's not going to be enough, capacity to ignite these. It's going to have to be something significantly larger than that. The technical rule on that is a maximum burning velocity of 10 centimeters per second, which means nothing to most of us, but we'll give you some examples here. So we start looking at the flammability. So down the bottom axis, going from left to right, is the burning velocity in centimeters per second. There's that 10 threshold that we mentioned a minute ago. And then up the vertical axis is the heat of combustion. So that's BTUs, right? Or BTUs per ounce or BTUs per pound of refrigerant, per quantity of refrigerant. So the A1s in purple that we're used to here, there's no burning velocity. So they're on the far left line. These new A2Ls are these guys all in yellow that we just mentioned a minute ago, plus a couple extras we haven't talked about yet, 1, 2, 3, 4 YF. Those guys are all down here. They're under the 10, but there is some flammability to them. right? Whereas in contrast, other stuff, other refrigerants like propane, which you can use as a refrigerant, I don't know why you would, but you could, that's way over here on the scale. So you probably have heard things regarding the new refrigerants saying, oh, they're flammable. You're basically going to be cooling your house with propane. You definitely are not. It is significantly closer to 410A than it is to propane or anything else like that. Even more flammable than hairspray on here. Here's another chart from HRI. It's kind of weird because by the way, I've stolen all of these pictures because I'm not a good artist. So I steal other people's pictures and combine them in ways that I like. So I give them credit, HRI in this case. But whoever made these, like this person made one and somebody different at HRI made this one. Because this one, as you go to the bottom left, it gets worse and upper right is better. So it's like the opposite visually. But in any case, the refrigerants we're talking about are over here in the upper right, and you have really flammable things down here like methane, gasoline, propane, etc. To get these A2Ls to ignite, here's a list from AHRI of things that cannot ignite one of these A2Ls, right? Including a cigarette, a burning cigarette, your lighter cannot do it, an outlet, a light switch, those kind of in little sparks cannot do it, your hair dryer, your toaster, all those things that are normally generating heat, taking your space heater and sticking it directly into the refrigerant, leaking out will not ignite it. You have to have significantly higher source of ignition, like some of these over here on the left over here, to be able to get that to happen. But most of these ones are not going to be able to do it. So it is flammable. We do have restrictions because of that. There'll be additional rules because of that, but it's not like it's freaky crazy flammable. And by the way, some of these refrigerants like R32 are used around the globe already. And some of these are already used in your car. I didn't realize that until like a year ago when I started researching this refrigerant issue. But even then, I bought a new car last week, and obviously the first thing I do is pop the hood to see what refrigerant it uses. And in fact, it's a new Ford truck, and it uses R1234YF, right? A lot of manufacturers are using that. Even 4 years ago, 50% of the cars that we have in this country that are being shipped in this country, used in this country, bought, however you want to word it, were already on an A2L refrigerant. So you're driving around in a vehicle, which obviously can be involved in accidents with one of these Y2L refrigerants. So if it's safe enough for the automotive industry, there should be not any freaky concern about using it in residential and commercial buildings that are not driving around and crashing into things. So some of the things that might happen, and I say might happen because the rules aren't like fully defined yet on this, on what manufacturers and or contractors may have to do in the field in order to make sure bad stuff doesn't happen in somebody's building, or in the case of this slide here, somebody's house. So obviously training will be part of it as these refrigerants become available. There'll be more training. Right now, there's a bunch of webinars from pretty much everybody on it. But if you're, for example, if you work with us and you're, a Heil Carrier Bryant dealer, we'll be having training classes in our lab, working with these refrigerants hopefully before you go out and try to install one, just so you're comfortable with it. One of the things that might happen is you might have to have refrigerant leak detection. So depending on the scale of the project, that may be something that comes into play, even at the residential level. So there's some discussion about maybe building that into the furnaces and fan coils, since those are on the indoor, and obviously the outdoor unit doesn't really affect anyone's health because it's outdoor. So these might be things that come up in terms of what you can do. You may be trying to limit your piping lengths to keep your total pounds of refrigerant lower, below some of the threshold limits. So some of these rules are going to be happening. If you look down here, here's kind of the limits on some of those applications, and it can be pretty small. So it's gonna be tough to not have refrigerant monitoring. But as those details become finalized by UL and others, we'll make sure that everybody's aware of how that's going to work. If you are, a Carrier commercial customer of ours, I'll just let you know what's happening in that world. Even residential, Carrier Bryant, day and night, Heil residential. So for the chillers that have 410A in them that are scroll chillers, we are switching to R32. As you saw earlier, the chiller phase in is happening faster than other product lines. And that's not unusual for some of these type of things anyway, because chillers are typically a longer cycle as it is. So the phase in's happening sooner. So I'm assuming Carrier's chosen to do R32 because they needed to make that decision like 3-4 years ago to get that rolling. If you have some of the larger machines that currently use 134A, so 23 XRVs, 19 series chillers, etc., you're going to be seeing 513A as the default choice there. And then for most of you on this call, pretty much almost everybody actually, based on the companies I was looking at, you're doing light commercial, meaning things that are like under 100 tons, and residential applications. And you're going to be seeing 454B on those. That was chosen because that has a pretty long shelf life because it has a really low global warming potential on there. So it should be able to take care of us for now, as well as the next phase down of refrigerants. And then we have one machine that was released several years ago, 19DV. It's a pretty specialized machine, but it is already on a newer refrigerant. It's always been on this refrigerant, and it has a freakishly low global warming potential. So if you have some kind of large scale customer like a hospital, university that also has all these goals and metrics related to their, environmental stewardship, this might be a machine you want to look at for those folks because it's basically the same, almost the same as CO2 essentially. All right, quiz question number 2. Remember, if you need a PDHs, you need to pay attention and do these. The final phase out date for all HFCs is what date? Yeah, and I also, everybody answered, and then I realized I worded this question about as poorly as I could word it, because I didn't say HFC phase out for new equipment or for the refrigerant itself. So that is on me. So if you answered either one of those correctly, then I guess I will have to mark you as correct on that. So that's my fault. I should have worded that better. So if you could see, you guys can see my screen right now, right? I think you can. I went back to that. So just to be clear, for equipment, we're phasing out at the end of 2024 for most kinds of equipment. And then actual refrigerant is like way out into the future. So I should have worded that question better. I didn't. So as long as you answered the third or fourth answer, I'm going to mark you as being correct on that. If you answered one of the two first ones, then obviously I can't give you credit for that. So my fault, my apologies. All right, moving on to equipment efficiency. There was some people typing in the question box that they didn't see. One person didn't know where to answer. A poll should pop up on your screen. Unless you have something weird going on, like if you have pop-ups disabled, maybe. I don't even know why it wouldn't pop up for someone. Or maybe if you have 2 monitors, it popped up on the opposite monitor. That could be. The DOE schedule. All right, so that was refrigerant stuff, and that's coming in a couple of years to longer years, depending on your version of that. The DOE changes for efficiency minimums are happening pretty much now at this point. We've been doing this presentation since I think February. I started doing this for people. So I've been saying, oh, in the future. Future's now. We're there. We're at that point. So these are things that are happening. So we already had the small boiler efficiency change at the first of the year. So if you're doing a small boiler, meaning under 300,000 BTUs, for hot water, your minimum efficiency is 84% currently. You can't get one less than that. So for most of these rules imposed by the DOE imposes the rule upon the manufacturer, and the rule is implemented upon the date of manufacture. So if somebody manufactured last December a boiler that was less than 84% efficient and you have it sitting in your warehouse, you can go ahead and install that. That is allowed. But starting on the first of the year, none of the boiler manufacturers could make anything less than 84% AFUE. Right? That's how almost all of these are going to work, except for one, and I will explain that when we get to that. Or actually, 2, I guess. So the first of this year, so less than 3 months from now, a bunch of rules are going to kick in. So small systems, both split and packaged. Small in this case means less than 65,000 BTUs. So that in fact would be 5 tons and under. Whether you're installing it residentially or commercially, it makes no difference. If it's single phase and it's under 5 tons and under, then you're going to have to follow the new rules. I have more slides that show how the rules kind of break down. So we'll hit that in a second. Same thing is going to happen for the heat pumps. When the ACs change, heat pumps go right along with that discussion, and we'll look at that. Commercial rooftops, so meaning bigger than 5 tons, also have an efficiency increase happening on the first of the year. And those same rooftops or other commercial furnaces, if you will, put furnaces in quotes because a rooftop is in fact a furnace, but there are other types of furnaces. That goes up from 80 minimum to 81%, which is not that hard to do. So that shouldn't be any burden for the manufacturers. It's probably the same technology they have now, just a different rating, just tested at a different point or something. And then commercial boilers, for some reason, that's not the first of the year, that's the 10th. So somebody didn't file the paperwork in time to have the minimum comment period or something. But the commercial boilers, meaning 300,000 BTUs and larger, also have an efficiency increase coming, both hot water and steam. And then there's other ones in the future beyond that. The one that comes up a lot lately is, well, you said single phase is happening in the first of the year. What about 3-phase small systems, 5 tons and under? Those will happen in 2026. There's a separation on those. There has been for a long time as far as these rules go. And that's because it's just like take some of the burden off the manufacturer to redesign everything right now. Let them get one thing figured out and then give them a couple of years to figure the next thing out. And there's other stuff that comes, along down that. And then you pretty much go back to the beginning of the list. And this isn't the whole list. This is the stuff that I care about. There's other stuff, refrigerators, washing machines, whatever. The DOE is just constantly, typically every 8 years, a new rule kicks in. Depends on when they process the paperwork, but basically every 8 years, we go back to the top of the list. So looking at the small single phase split systems and small single phase package units, 5 tons and under, we mentioned refrigerant changes coming down the pipeline, right? That's at this point in the discussion, that's in the future. But right now, starting the first of the year, we have these efficiency rules that we have to deal with. And it's pretty big impact. There's a pretty big increase. And pretty much most of the products that you see in the market today do not qualify. So 70% of them do not meet the minimum efficiency. So 30% of the things you know and use now, you'll be able to continue using, although there might be a slight model number tweak or something. But then the other stuff is all gone and new stuff takes its place. And all products, whether they meet the efficiency or not, are going to have to be retested or re-rated. So just so you know, like with these split systems, everything's not tested. It's only like sample tested. Reason being is the testing is this furnace or air handler with this evaporator coil with that condensing in it. And you can think of how many combinations that would cause. Hundreds of thousands of combinations per manufacturer. So they don't make them test them all. They rate them all. They model them. And then they sample test certain ones to see if the modeling is right. But all of those have to be re-rated. Everything, 100%. So the minimum efficiency, this is what was supposed to happen. It's going to be slightly different when you see in a second. But for us in the north, 99% of you people on this call are in the dark blue area. So I'm only going to talk about that. If you're in the south, you can screenshot this and then figure it out on your own. No, I'm just kidding. You can call me if you want. It's going to go from 13 SEER to 14 SEER for AC. And then for heat pumps for the whole entire country, it goes from 14 SEER 8.2 HSPF to 15 SEER and 8.8 HSPF. For those who don't do a lot of heat pumps, you might after today, but for those that don't do a lot of heat pumps, HSPF is heating seasonal performance factor. It's the SEER for the heating side of the heat pump, essentially. So it was supposed to go from 13 to 14 and from 14 to 15 on the heat pumps, but simultaneous with this change, there is another change that is actually happening, and that's on the testing procedure itself. So currently, small split systems are tested with 0.1 inches of external static pressure. For pretty much all of you, you realize that never, ever happens unless you have a fan coil in a closet and there's like a duct coming out of the closet and that's the whole system. And then even then, maybe not. So the new testing procedure is going to be at 0.5. So 5 times higher static pressure, which means more internal indoor fan energy. And fan energy is part of the SEER and HSPF calculations. So there will be a derate will happen. If you were at 13 SEER before, all of a sudden your exact machine that made 13 SEER last year will now be at like a 12 SEER machine or something like that this year. So this new test procedure is happening, and to attempt to avoid confusion, they've given them new labels. So instead of SEER, it's SEER2, EER2, HSPF2. So starting the first of the year, you'll be using those terminologies and using those sections of the HRI tables instead of the current ones we use today. Because those two things overlap and happen, this is what's actually going to happen. Instead of going from 13 to 14 SEER minimum, the new minimum will be 13.4 SEER2. So from 13 to 13.4 doesn't sound like a lot, but because of the new rating, a 14 SEER is basically equivalent to a 13.4 SEER2. Same thing happens on the heat pumps. The new minimum will be 14.3. On the HSPF will be 7.5 if you're doing a split system. So hopefully that makes sense for you guys using small systems. Once again, this is the system. You can put it in a house or you can put it in a small office building, and it's still going to be these ratings. If you are in the north in dark blue, which most of you are, you could still install this old stuff after the first of the year. That's not true for people in the south. They can't do that. So all those DOE rules I said were policed at the point of manufacture, except for one. This is the one. The AC system specifically is not policed at the point of manufacture. It's policed at the point of install. So after the first of the year in the south, they can't install the old stuff, but in the north, we can. So it's kind of weird in that regard. But most of you guys don't deal with the south unless you got a friend's vacation home, so who cares? So I'm going to skip that slide because I think I just explained that. So lots of things changing, as we mentioned. Ways we're getting there, and we meaning, Carrier, Bryant, Heil, etc. There are new coils, so that will help improve performance. You've probably seen, if you do any residential work, you've probably seen the new V coils. It's an A coil, but it's upside down, so it's a V coil, right? Very creative naming, obviously. But it ends up with this really small drain pan, which is super skinny, doesn't take up a lot of area, and hence it helps out with airflow. And then the coil technology is a microchannel style coil, which helps out with heat transfer. So this is one way to get better performance out of existing cabinet sizes. Otherwise, we'd have to go to those really tall A coils, which is not fun. So this is basically the same size as an N coil for most sizes, maybe slightly bigger on a couple sizes. But that's one way they're getting there. So on entry-level furnaces, so on variable speed furnaces, you're in good shape from a fan energy standpoint. But on entry-level furnaces, we only have 4 or 5 speeds to work with. That's a problem. So now the manufacturers, or at least in this case, the Carrier family of brands, Bryant, etc., has a new 18-speed furnace coming out next year, which will help us get better efficiency as well. And then the same thing's happening on the fan coil, getting better fan technology in the fan coil to help the SEER along in the HSPF. For single phase stuff, Department of Energy rules will kick in, like we said, first of the year, and you'll have to go to SEER2. 3-phase stuff stays at SEER until we get to, well, this says 2025, but it actually will be 2024. This is a slight error in that slide. But then we'll kick into SEER2. No, 2026. It'll be opposite way. It'll be SEER2 over there. For larger rooftop units, we had the efficiency bump, larger meaning more than 65,000 BTUs. We had the efficiency bump in 2018, and now we have another one coming the first of the year. It's another 15%, so we had a 15% bump then. We got another 15% bump coming now. It is only for IEER, which is part load performance. It does not have any rules for EER, and it didn't in 2018 either. And then it's going from 81 to 82% efficiency on the gas side, which is not that difficult to do. Reason why part load is important, you've probably seen this in many of my other classes. In Chicago and most places for that matter, a full load EER day, 95 degrees, pretty much statistically almost never happens. But we have lots of days that are at part load days before we kick our economizer sequence in. So it's better to be efficient there than it is to be efficient at full load EER. That's why everything's triggered off of IER now. And the standards and the DOE, and probably very soon the codes, are starting to ignore EER in its entirety. You guys probably know how IER is calculated. Basically, they load it at 100, 75, 50, and 25%, see what the efficiencies are at those levels, and then average them out with a weighted average, putting most of the weight on B and C. because that's where you spend most of the time. You're hardly ever at full load, and you're very seldom down here at this low part load because you're probably in economizer mode at that point, or at least partial economizer mode. These are the new efficiency tiers. It works the same way the codes work, or IECC or 90.1. You got certain size ranges, and it tells you what you have to do. Then the next size range, what you have to do, and the next size range and what you have to do. These are policed by the manufacturer. So if the manufacturer builds one on December 31st and ships it to you, that's fine. You can install it. They just can't build anything worse than these tables after that date. So for example, we just take one example on here. Let's say you have a rooftop AC system. Let's say it's 10 tons. So here you are, AC. If you have electric heat, you will need to build, you mean the manufacturer, have to build a 14.8 IEER minimum unit, whereas the current minimum is 12.9. So it's a pretty big leap. If you have anything other than electric heat, meaning you have gas heat basically, or I guess you could have a hydronic coil or something. But if you have gas heat, you need to be 14.6. It's always a little bit less restrictive on the gas heat versus electric heat, because the gas heat for the cooling mode, we still got to shove air through a heat exchanger that we're not even using. So there's always a little bit, a couple tenths of a point there benefit. And it works the same way for all of the other ones. The sizes just get bigger and bigger as you go. And the bigger you go, the lower the nugget gets, because you're space constrained at some point. So this is not something you would have to police as an engineer or a contractor. It's just that you will just, shortly after the first year, you just won't be able to get these lower efficiency units anymore. You have to get the higher efficiency units, which will cost you more money. So it affects you from a budgeting standpoint. But if you happen to have an old one, you can go ahead and install it. And then on the gas heat side, I think one of my sides might have had an error. I said 82%, but it goes from 80 to 81% for any commercial furnace, which is above 225,000 BTUs, and a rooftop is in fact also considered a furnace. So 81% is your new minimum from the manufacturer to be able to build. Mike typed a question in. This all depends on the states adopting these codes, correct? No. Right now we're on the Department of Energy rules. We haven't gotten to code yet. So this is happening for everybody in every state, all 50 states equally. You will not be able to get things that are the first level here. You won't be able to buy that anymore. You won't be able to buy that anymore. You won't be able to buy that anymore. You'll have to go down to this level. Everybody equally across the country, not state dependent. All right. So to kind of summarize that up, these are things we care about now. This is problems for us to worry about into the future. Small split systems, single phase and packaged single phase under 5 tons. We're going up to 14 SEER. If you have a heat pump, it goes to 15. Larger units, it's a 15% bump on IER, depending on the tonnage that you were at. Gas heating goes up to 81% on the rooftops. And I didn't have a slide separately on here for the boilers. I should probably have done that. I'll add one in for the next time, but there's a little bump in efficiency on the boilers up to 84, 85. This is about as high as you can get, by the way, without condensing. And you don't want to be like semi-condensing, because then you got to build the whole thing out of stainless steel anyway. So you're probably going to see some actually right now, almost no one has 84 and 85% efficient commercial boilers. It's like a rarity. So there'll be some manufacturers that take their 82s and 83s and tweak something and re-rate it to get there. And there'll be other manufacturers that just flat out stop building non-condensing boilers, and they'll only offer you their 92, 94, 95% model. So you'll have a limited amount of choices on where you can get in an old style boiler, meaning that it vents out, sheet metal instead of venting out PVC. All right, quiz question number 3. My polls here. All right, new minimum efficiency for small tonnage split systems in the north, which is where we live. Your choices are 13 SEER, 13.4 SEER 2, 16 SEER, and 16 SEER 2 will be the new national minimum. Oh, you guys are really doing good on this one. I must have worded the question better on this one. Everybody's doing good. Oh, and then somebody got it wrong. Come on, man. Come on, man. All right, 51% of you answered. I'm going to give it another 10 seconds. All right, I'm closing it in 3, 2, 1. All right, 84% of you got the correct answer, which is 13.4 SEER 2 will be your new minimum efficiency for ACs up here in the north area where we all live, going forward, starting on the 1st of the year. All right, you should be back to seeing my screen again. All right, let's move to energy codes. So to Michael's question earlier, what we talked about a minute ago was Department of Energy rules. Generally speaking, police at the point of manufacture. Manufacture, you can no longer build that old thing. You can only build this new, more efficient thing. And hence the supply chain can only sell that thing because it's all that's available. Then you have energy codes, right? We're pinching the energy efficiency thing from at least 3 different angles. You have Department of Energy, and this has been going on for decades. Department of Energy, you have local energy codes, and then you also have local utility rebates, right? So one tells the manufacturer, stop building that thing. The other one tells people, stop installing that thing. And the other one says, well, go back to the things you already installed and we'll pay you to switch it out to something more efficient, right? Those are basically the 3 ways we're trying to get more efficient as a country. Residentially speaking, right now in Illinois, which is like 93% of you on this call, we're on 2018 IECC. So that's where we're at residentially. Indiana folks residentially are in the same boat. And for you guys in other areas are a little bit further behind on the residential code. Residential, things that are changing. And by the way, Chicago just adopted the 2021 IECC last month. So that's happening immediately for Chicago. That's in effect now. Illinois has not finalized it yet. It was supposed to be like September, then they said October. Now the last date I heard was December. So we'll see. Till it happens, it doesn't happen, but you kind of need to know about it. And then all of a sudden one day the light switch will flip and you'll have to do it, right? So Illinois has not gone statewide with 2021, but of all the states on this map, Illinois will be first. So the rest of you guys can just see how badly we screw things up and then you can kind of follow suit. Residentially, big changes that are happening. Windows are changing. Doesn't matter a lot to us on this call because we're HVAC, but it does mean your load calcs will continue to get smaller and smaller and smaller. That's been happening for a long time now, right? But most of us are in climate zone 5, right? So we're over here on this side of the chart, and you can see there are a bunch of changes there that are happening. So just plan on knowing something, looking at a different table when you decide to do your load calcs on new construction or on a gut rehab project. Same thing happening on the insulation. Climate zone 5 is where we're at, and there is the 2021 IECC, and then there's the proposed Illinois amendment because Illinois is not finalized yet, so it's technically proposed. But in any case, same discussion as Windows. It's not directly affecting your HVAC life, but as you are sizing rehab and new construction residential projects for HVAC, just know you're looking at a different table to get a higher insulation value, which means you have a smaller load calc, right? Stuff that is changing for us on the mechanical side residentially. Duct leakage testing currently is only required if you run your ducts outside the conditioned space, meaning you put them in an attic or a crawl space or a vented basement or something like that. That is changing, and now you will have to test them even in the conditioned space. So now 100% of newly installed ducts have to be tested residentially for leakage. That's the hard part. The good news is they're giving you a fairly high, double the old limit. It was 4 CFM per 100 square foot of home. Now it is 8 CFM per 100 square foot of home. So it should be a little bit easier to get there. I mean, it's still hard, but it's a little bit easier to get there. Because if you're leaking air into the conditioned space, it's like, okay, well, you're still getting the air. It's not getting it to the right space. And then if you deal with any of these small fans, the efficiency minimums on those are all increasing as well. So like ERV stays the same because that's pretty low as it is. But like bath fans and stuff like that, efficiency is improving, like basically doubling for the most part on some of these. And then residentially, you're gonna have to do the additional efficiency package. This is something we've had on the commercial side for a long time. Now you will have it on the residential side. What that means is you do everything in the code book. And then on top of that, you go to this other section of the code book and there's a list of things you can choose to do. And you got to pick one of those things and do that. Anything you want. You want to make better windows? Fine. You want to make better HVAC? Fine. You got to pick something off that list and do the extra thing on there. So that's going to be something new on the residential side. That'll obviously be very difficult for inspectors to handle and all of that because everybody be doing it different. So that makes it a little bit of a mess. But that is in fact what the rule will be. And then Other proposed amendments for Illinois, I'm gonna go through these quick because they're proposed, and until they happen, they don't really happen. But Illinois, as in the past, is looking at possibly tweaking the air leakage for the whole house assembly. So you do blower door test on every single house in Illinois and most states for that matter, and you got to get down to a certain leakage rate on the house. So this is what Illinois is probably looking at doing. So 5 air changes per hour, performance, 3 prescriptive. Most of what you guys do is prescriptive, meaning I do the things in the book and then that's it. 3 is what your new nugget will be. You'll be allowed to be leakier if you go the performance energy modeling route, but then you gotta do a better job on something else, make up for it, kind of thing. Another proposed amendment is that for very small residential homes, instead of having that 4 and 8 CFM per square foot leakage rate, they might just go with a flat 60 CFM, because on really small spaces, you don't have a lot of square footage of home to make the math work out in your favor, but your air handler or furnace is equally as leaky as someone with a bigger house's furnace or air handler would be. So it becomes very statistically hard to meet the levels on these really small houses. So that limit's getting tweaked there, or could get tweaked there. And then make you label your ERV controls. I don't know why you wouldn't do this anyway, but apparently people don't. So now we got to put it in the code. All right, commercial side, which is many of you, in fact, more than half of you on the commercial side. We are also in Illinois on the 2018 IECC. Minnesota's there with us. Other states are on very similar versions, but not quite there. Chicago, just like residential, switched last month. Illinois as a whole state will probably be switching in December. Could be a couple months later. It just depends on how fast they can do their paperwork, which is always a challenge. Major updates on the commercial side of IECC 2021. There are some building envelope changes, just like there was residential. That will affect your load calc. We're not going to go through those in detail. Just know those are happening, and you need to look at different tables when you calculate your loads. There are some equipment efficiency improvements. We will look at those. Some lighting improvements, also that affects your load. So it's a few things like that. The climate zone map, if you don't pay attention to ASHRAE, you wouldn't know this yet, but the climate zone map is changing. It doesn't change for those of us in Chicago. We are still climate zone 5A, but if you are up in Milwaukee area, which was a good, I think 8% of you on this call, your climate zone does change. So when you guys switch to the new code, which I don't know if that'll be next year or 3 years from now, but when you do, or if you get a project where you're supposed to do it based on the current 90.1, because that's what they want, you are in a new climate zone. Basically, you're now part of Chicago. I know you're very excited about that. Most people in Milwaukee want to be part of Chicago, obviously. So you are now lumped in with us, and you can become Bears fans, and it's going to be great. You're going to love it. Major changes, efficiency equipment for HVAC. There's a bump in there. It's not going to be that painful in Illinois because we're already going to see the bump anyway because of the Department of Energy rules. And in fact, everybody else, you're going to get the bump even though you don't have the code book. So it's just going to happen for everybody. So let's look at that in a little more detail. Okay, I didn't blow it up big enough to see it, so that's a problem. But there's new tables in the code book. These are out of the 90.1 code book. I could tell that just based on the table numbers and the visual look of it. But IECC has the exact same table. So 90.1, 2019, and IECC 21 are identical tables. So you can use either one of those books and you get the right answer on that. There are new tables because we didn't have enough tables on the first 12 pages. We had to add more pages. So different types of equipment that never had their own table in IECC now do. Dedicated outdoor air units now have their own rating. In the past, it was kind of like, well, I got this dedicated outside air rooftop unit, but I can't put it under the rooftop rating scenario for AHRI because running 100% outside air through it, it won't be very efficient, blah, blah, blah. What do I do? That goes away now. You get your own table. Go to this table, see what it says, right? VRF has had its own table in 90.1 for a few cycles now, but now it finally has its own table in IECC. So instead of trying to go and look at some heat pump table and apply it to your VRF job, you got your own VRF table there. There's now tables specifically for heat pumps and heat reclaim chillers. So that's a different change there. In the past, you basically, if you put a heat reclaim chiller in, you would just go look at the regular chiller ratings and just meet that. Now, if you put a heat reclaim chiller in, there'll be a chiller efficiency you have to hit. And then there'll be another column there, or actually multiple columns for the COP on the heating side that you have to hit. So heat reclaim chillers, which are sometimes required by code in general, have both a cooling and heating performance table associated with them now. Fault detection and diagnostics. We've had this on economizers for a few years. Now, in addition to economizers, it is being added to all systems, right? It's a giant leap there, right? So what that means is if you have buildings that are more than 100,000 square feet, so this would be, you build a new building or you gut a building and you rehab it. It's more than 100,000 square feet. You're going to have to put a building automation system in. I've gone through the exception list on this with several people already, and I can't typically find an exception. I'm like, well, I don't really want to do it because I don't really have hardly any pieces of equipment. It's a giant storage facility. I only got like 5 rooftop units. Doesn't matter. You still have to do it. So there's no real exceptions that are going to get you out of that. So just plan on putting building automation systems on your larger scale projects. Honestly, if you have a building that big, you should be able to afford a building automation in the budget somewhere, even if it's a pretty small system. If you have mom and pop buildings and stuff like that, obviously they don't have to do that. They still got to do it on their economizer on the rooftop, but that can just report to the thermostat and not have to have a BAS. So there's a whole entire section that defines what that exactly means. Most of you guys aren't controls guys, so you probably don't really care about the exact details. Just know that you need to be asking for this, citing the new code, talking to your controls guy to make sure that they build that into their estimate and plan on doing that for you. Some systems, some manufacturer systems already have this. It's been like an add-on package you can get. Now it's going to be something they're going to have to bid standard on their quotations. If you're doing small systems, kind of like we had on the residential side, you're going to have these new efficiency requirements on there for those small fans. This is going to come up a lot on like condo buildings and stuff like that, or even a bathroom fan on a small office building, right? You're going to have to put in a fan that meets a certain efficiency, and it matches up pretty well with what the residential side was, because you're probably using residential sized exhaust fans in these scenarios anyway. Other control changes. The most exciting one for most of you is that VRF no longer requires an economizer. Currently it does, and obviously that's extremely difficult to do, bring in 100% cooling through a VRF system when your ventilation duct is only sized for like 20% of the whole load. So basically you can't do it on a VRF system. So what you end up doing on a VRF system is getting some kind of exception, some kind of code variance, or doing an energy modeling pathway. You no longer have to do that. As soon as you have a VRF system, you no longer have to fulfill the economizer requirement. They're basically saying, yeah, you're already saving a boatload of energy, especially if you're doing a heat reclaim VRF system, you're good. You don't have to do the economizer thing, which is obviously very difficult to do when you don't have 100% CFM duct system there. Demand control ventilation gets stricter. We used to be at 40, then now currently we're at 25. We're going down to 15 people per 1,000 square foot ratio. You have to put in a demand control ventilation system. So that starts including a lot of areas that didn't get included before. Before it was like movie theater, conference room, that kind of thing. Now it's like lots of places. Just general office area, you're probably going to have to do it. A store, you're probably going to have to do it. Oh, I missed one, sorry. We've had optimal start routines required by code for a while. Now we have an optimal stop routine that's going to be required, which means that you're going to, if their set point is, let's just say it's, I'll make up numbers. You cool the building to 74 degrees when it's occupied and 80 when it's unoccupied. As you get closer to closing time, you no longer will control the 74. You'll start letting that flow up to 74 and a half, 75, 75 and a half, and eventually 76 and tell people to get out of there, right? Obviously the occupants can go and override it if they're going to work late, etc. There are some additional rules on the control side. For parking garages, water source heat pumps. I know I'm just reading those and not giving you any details because time is tight here. But if you are a controls guy, there are some things you want to research. Somebody asked before if these slides can be made available. Yes, they in fact can. I can send you guys these so you have them. Everyone should have registered with an email, so I should be good there. I'll post it somewhere and send you guys a link to it tomorrow. Supplier temperature now has some new rules. We've had supplier reset on VAV systems for a while. Now we have some rules to better deal with dehumidification. So once again, if you're a controls guy, you need to take a look at that section. ERV rules are changing. This one affects a lot of you. In fact, it came up with somebody the other day. We used to have an exception for ERVs. If all of your exhaust air wasn't in one spot, you didn't have to follow the ERV rule. You lose that exception on those apartment building jobs. So if you want to run 32 exhaust fans, one from every apartment building, you still have to do the ERV now. You no longer get that exception that you used to get. So you should probably plan on having a centralized ventilation and a centralized exhaust system if you're designing an apartment building that is going to go ahead and be built next year, or City of Chicago built right now. You'd have to do this. And then the efficiency on cooling stays the same for an ERV, and it bumps from 50 to 60% on the heating side. That's not that difficult to do. Most manufacturers can hit that, so that's not a problem. So the big thing for you is you're no longer getting an exception for mid and high-rise residential buildings not having ERVs. You're going to have to do it. And then there's some new rules if you do heat recovery stuff in hospitals specifically. There's some new rules to pay attention to there. You should already be looking at heat recovery for hospitals anyway, just because it's good practice, because you have a heat and cooling load simultaneously a lot of the time. But now they're going to be forcing you to do it. Whereas before you might have done something like reclaiming, heat out of your cooling tower loop. You won't be doing that anymore. Now you'll actually have a heat recovery chiller. And then some refrigeration, escalator, spa changes, which most of you don't get involved in. Computer room changes. In interest of time, I'm blowing through these, and I apologize. The thing I want to mention here, this doesn't really change. This is proposed, but it'll probably go through because it's been this way since 2006 anyway. Meaning that you can every town, every county, every type of building in the whole state of Illinois has to follow the new code when it goes live. There's no option for the village of whatever to say, nah, we're going to stick with the old code. They cannot legally do that. And then cities that are of a certain size or certain code vintage are allowed to be more stringent than that. Like Chicago just adopted a more stringent code. They're above the 1 million threshold of people. They're allowed to do that. So that's still the same as it always was. And then what's happening on top of that for Illinois specifically is we're going to have our first stretch code. Some other states already have that. So that from your standpoint and mine becomes a little extra work because now there'll be 2 state codes. There'll be the base state code, IECC 2021, then there'll be the stretch code. The stretch code will be more stringent, more difficult, more efficient than the base code. And then everybody in the state has to do the base code, and then some towns could choose to adopt the stretch code. They can't adopt their own code, but they can do the stretch code. So it's better than everybody doing whatever the hell they want, because that's a mess. So at least there's only 2 codes you have to learn, but there will be in fact 2 codes instead of 1 that you have to pay attention to. All right, quiz question number 4. True or false? From IECC and 90.1, the equipment and minimum efficiencies of IECC are updated to match 90.1. This should not be a hard question. We should be able to power through this in 20 seconds. So far, everybody's doing good. It's not a trick question. What other questions have I missed from you guys while I'm waiting? Somebody has an audio problem. In regards to this, probably based on the time, was probably the residential duct sealing. This is only for newly installed duct, not replacement jobs. Replacement jobs of ductwork would be also newly installed duct. So if you replace equipment and you keep your ductwork, you don't have to do anything. But if you replace ductwork, then you will have to test the leakage. So even if you replace 20 feet of the duct, or you add a branch run over there, you'd have to test the leakage of it. So the code in general for HVAC doesn't distinguish between new construction and repair, replacement, modification jobs. It's the same thing. For some things like roofs, it's different. But for HVAC, there's sections for it. When you go to like the existing building section, it basically refers you back to the same section you were already in for new construction. So anything you do for new construction, you also have to do when you replace something. The general rule is the thing you touch, that thing has to be brought up to code, but the other stuff doesn't. So if you replace one rooftop and the other rooftop on the other side of the building is being left alone, that's fine. It can be left alone. If you're doing a residential job and you change out the condensing unit has to be updated to it, the new code, as well as whatever controls the condensing unit, i.e. the thermostat. But the ductwork, you didn't touch it, you don't have to do anything special. You replace the ductwork or change it out or add to it, then you do have to do something special. All right, ending that poll. 93% of you guys got that correct. Yes, the tables will match for 90.1 and IECC. All right, let's get the tax credits done. I know we're going to probably go a couple minutes over, but this is important. This is basically brand new as of 5-6 weeks ago. So first off, let's talk about the tax credits that already existed that got re-enabled. So what does that mean specifically? So residentially, we've had 25C tax credit for a long, long time. It will be this in the future, but right now for 2022, retroactive to the first of the year, all of these, by the way, are reenacted and retroactive to the first of the year. You can do the old tax credit for a consumer, for a residential consumer, which means $300 for an AC or heat pump, 16 SEER type stuff, $150 for a furnace, 95% minimum, and $50 for the fan, for a grand total of $500, which has a current lifetime cap of $500. Then, starting on the first of the year, we go to these new amounts, right? So for each one of these, two things happened. They enabled the old expired credit from 2021 and earlier and extended it for 2022. And then they created brand new credits for 2023 and beyond. So for the first of the year, and I think it's 10 years after that, we go to this new credit where you can get up to 30% of the installed costs, which is it's capped at $600 for your AC, $600 for your furnace, and it's a $1,200 annual cap. So the old one, when you combined everything, was $500, and it was $500 lifetime cap. The new one, it's $1,200, and that's an annual cap. So if you wanted to get a new furnace and AC every single year, or you want to do your upstairs furnace and AC now, and do your downstairs furnace and AC next year, you could put those two credits on each of those two years there and get it done. There's an exception to the $1,200 annual credit for heat pumps specifically, and heat pumps can go up to $2,000. As you're going to see with everything going on, there's a ginormous movement for electrification, and heat pumps are a big piece of doing that. So heat pumps are getting incentivized all over the place. 25D is the heat pump geothermal credit. We've had this for a very, very, very long time. It was set to expire the end of this year. So we were down to 22% level, 22% of your installed cost you would get back as a tax credit. And it was going to expire at the end of this year. And that's still the way it is at the end of this year. But then, these dates are not perfectly correct. It should say 2023 here. Then starting on the first of the year, instead of the whole thing being done and over with, they're resetting the clock. They're taking you back to the 30% and letting you get 30% for the next 10 years. And then it starts phasing out after that again. So if you got a geothermal project that you're working on now, you may want to finish it after the first of the year and get 30% tax credit instead of 22% tax credit, residentially speaking. 45L was also an expired tax credit that's been reenacted. It is the same for 2022, retroactive to the first of the year that it was in past years. And then at the start of 2023, it goes to these new dollar amounts. SF is single family, MF is multifamily. So you get these tax credits if you're building new residential space. You can get these new tax credits on there at the first of the year, old dollar amounts prior to that. 179D is the commercial version of all of these things. Instead of having these individual buckets, it's one big bucket, and you do it via energy modeling. You model it to a baseline, which is ASHRAE 90.1 2007, and see if you can do better than that. Currently, you got to do 50% better than that, and you can get $1.88 per square foot. Or you can even do 60 cents, 60 cents, and 60 cents for envelope, lighting, mechanicals. But if you did everything, it'd be $1.88 you can get to for that. But you got to be 50% better than that baseline. That has been going on. That was already previously extended a couple of years ago. It has no end date, and it's just been going on, infinitely for the past 2 years. It has been that way. Starting the first of the year, 2023, instead of $1.88, it goes to $5. You can get up to $5 instead of $1.88. There's no longer buckets for HVAC, lighting, etc. It's just all one bucket. Energy model it. And you can get to the higher dollar amount if you're 50% better than ASHRAE 90.1. If you're less than 50%, you go on a sliding scale. So 25% being the minimum, 25% corresponds to $2.50 per square foot, 50% corresponds to $5. So it slides from 25 to 50. It slides from $2.50 to $5. So that's nice. Then if you do a little better than 25, you get 33%. There's some bucks for doing that. So every single thing you decide to do in your building could have an effect on there. You also have to have prevailing wage for your construction project. And if you don't do that, you're not eligible for the top dollar amount. You get knocked down to a lower dollar amount. So they're trying to incentivize you as part of that package to do the prevailing wage. So hopefully that makes some sense. The wild card, that hopefully you guys know what the modeling stuff is there. You know what Energy Star geothermal is. This is kind of the wild card on here, the high efficiency CEE tier. I'll show you what that is currently, what SEER and HSPF you got to be at. But as you know, on the first of the year, all the legal minimum efficiencies change, which means CEE is also going to change its tiers, and that's not fully finalized yet. So it's kind of a wild card at the moment. It's known what you have to do this year, but it's not exactly known what is exact SEER you have to be, or SEER 2 rather, for next year. So I'll try to explain that. Then on top of that, the Inflation Reduction Act, other than just re-enabling these tax credits and extending them and increasing their dollar amounts, which it did for all 4 of those, it also added a couple new ones. And it's not really clear what's going to happen here. These are not tax credits. These are rebates. And they'll be administered by each individual state. So the federal government is taking tax revenue, giving it to the states based on whatever formula they decide for populations and all that. And they'll each have a bucket of money to be able to spend. So on the tax credits, there's no limit. Like for the next X amount of years, you can keep doing this, right? Everyone can keep going, plugging along. Oh, I forgot to mention this commercial 179D. It used to be one time. You could do it once for your building ever. Now you could actually do it every 3 years if you wanted to. So you could wait 3 years and you could do it again, right? So that's kind of crazy. But these tax credits are things that we kind of know how to deal with. We've all dealt with them in the past. These rebates are a wild card. Tax credits, it just keeps going and going and going. There's no maximum dollars funded. These state rebates, there's a maximum dollars funded. So there's $4.3 billion, which sounds like a lot of money, but now you divide it amongst 50 states and X amount of homeowners, and all of a sudden the money starts, dwindling down pretty quick. So I'm sure these will probably be all gone quickly. But with that being said, you can get up to, this is on top of the tax credits and on top of your utility rebates, you'll be able to get up to $8 grand on a heat pump system residentially. And then there's other non-HVAC stuff that you can also do on there. There are some rules. You have to be in a certain income range to get the full amount. If you're in a higher income range, 80 to 150% of the medium, you'll get a reduced amount. And if you're above 150%, you wouldn't be eligible at all. This will be administered by the state, and it's not known yet how the states are going to choose to do this, especially the states you guys are living in. It's probably not going to happen. It's definitely not going to happen on the first of the year, but maybe sometime in the summer, as we're getting ready to go into the heat pump heating season, maybe Illinois will have a plan figured out. I'm hoping that what they do is they just give the money to the utilities and say, you guys go ahead and tack this onto your utility rebates because you already have an infrastructure for that. But if they try to do their own thing, then so be it. That's what will happen. And then unrelated to HVAC specifically, there's whole performance rebates that work the same as these ones, state administered, currently undefined income limits, but it'll be for doing home performance type stuff. So in regards to the CEE, right? So these tiers right here, the highest efficiency tier, if we weren't changing the SEER ratings of everything, this is what you would have to hit. You'd have to hit 18 SEER and 13 EER. If you had a split system residential, if you had a heat pump in the northern climate, you have to hit 18, 11.5, 10 HSPF. And then if you had ductless systems, you would have to hit 16 SEER, 12 EER, 9 HSPF. The SEER and HSPF aren't too hard. The 12 for the EER is pretty difficult for a physically small condenser coil surface area. So that one is a challenge. That's what it is currently, if it was that way, but obviously it won't be because we'll have SEER 2 instead. There won't be anything, SEER won't exist. This is the current proposed answer from CEE, not yet defined, so currently being under debate, but you would have to be 17.1 SEER 2 and 12.3 EER 2 for an AC, down here at the bottom for a heat pump. So this doesn't really matter for the tax money and the rebates. This is what would, I'm sorry, one more slide. This is what would matter for heat pumps. So northern climate, 17.1, 10.9, 8.5, and then a brand new rating. If you didn't know, we do COPs at 47 and 17 degrees outside. There's a new rating to start doing them at 5 degrees outside, because people want to know how good their heat pump is going to be on a cold day, right? So that's a new thing you'll have to be able to hit. There is some discussion at CEE if they just maybe don't use the SEER 2 and they just use the SEER 1 as the top tier to make it align up with Energy Star and make everything nice and clean and easy. So hopefully that happens, because that would be easier to deal with than the top tier would be. We'll have to give you the answer on that when it comes. And then for ductless, 15.2, 10.6, 8.1. Non-ducted heat pumps. Oh, I did the same thing again. Wait. No, that's package. Sorry, that's ductless. Geez, ductless is no longer called ductless in the new CE. It's called non-ducted. Sounds like ductless to me, but there's your target. All right, last thing, rebates. I know we're over the limit here. Why don't I do the quiz questions and then I'll do the rebate stuff for anybody who wants to hang on. Oh, I got to do at least 3 slides to give you the answer for the quiz question. Damn it. All right. So NIPSCO rebates residentially are unchanged since the first of the year. So if you deal in the NIPSCO area, you should be good to go on this. Nothing's new. You can double dip. What I want to tell you about this, you can double dip your heat pump rebate here along with the current tax credit, and you'll be able to do the same thing next year when the tax credits are in fact higher. What am I clicking on here? Switch screens. Commercially, no changes for NIPSCO recently either since the first of the year. So all those things are there like we had it before. It does include air source heat pumps. There's rebates for regular DX cooling systems, VFDs on your fans and pumps, all that normal good stuff you're used to on a rebate, gas rebates on your boilers, etc., etc. No changes. Same thing in Wisconsin. No major changes recently. There was a change that I want to point out residentially in Wisconsin for you guys that are doing work there. Starting on June 1st, you have additional money on dual fuel heat pump systems. So on a heat pump in Wisconsin, residentially, you get $300 if they have electric or propane or oil. But if you swap it out for natural gas, which is generally speaking more cost effective than those other technologies, they give you a much bigger dollar amount. They know they basically have to pay you to convince you to stop using gas. So there's a pretty good dollar amount on residential heat pumps there. And then commercially, all the stuff you're used to on the Wisconsin Focus on Energy program is still riding there strong. All right, ComEd. Commercially, there's different ways to get rebates. There's the standard rebates. You go online, you download the application, you fill it out, you get your rebate for demand control ventilation, economizers, rooftops, chillers, etc. Same as it's always been. You can still do that. There's a midstream rebate program that started up, I think 2.25 years ago, something like that, where instead of doing this application, you work with your distributor, hopefully TEC in this case, and we can give you rooftop rebates as well as heat pumps and PTAX for significantly larger dollar amounts. It gets processed by us instead of a third-party processor for ComEd. Basically, they convinced us to do the work on the paperwork side to help you get your rebate, right? If you're doing standard rebates, probably don't do that for rooftop units, but that's where you're going to find your chiller rebates. And not only do we have the regular chiller rebates, but there's also the chiller with VFD automatically gets $100 per ton without even doing any math on the IPLV. And if you have an oil-free chiller, $200 per ton without having to do the IPLV math. And that's the kind of the summary of that. $100 per ton VFD, $200 per ton for the chiller. You got to hit minimum code efficiencies, which is expected, obviously. But then beyond that, there's no extra rules. So if you're just like one little hair above code, you qualify as long as you have either a VFD or you have a mag bearing chiller. Oil-free bearing chiller is a generic way of saying mag bearing chiller. So I don't know any other way to do it. All right, those midstream rebates, you got to hit the CEE rooftop tiers, tier 2 and tier 3. Tier 3 is really hard to do. Tier 2 is not that hard to do, but you get a pretty good dollar amount per ton if you can hit those nuggets. There is no EER requirement. It's just IER, or for the little ones, SEER. All right, these get processed through us at TEC. And then there's a heat pump version of that. And then there's some PTAX you can do on that program. Skip that for now. Skip that for now. All right. The last thing I need to show you before we do this quiz question. ComEd residentially, we've had these rebates also processed midstream through your distributor, i.e. TEC. The AC rebates have remained unchanged for a couple of years. Heat pumps have always been 2 to 3 times, in some cases even more, like 16 SEER, were 2.5 times the dollar amount on a heat pump versus an AC. And then starting September 13th, for anything installed September 13th through the end of the year, These are your dollar amounts on heat pumps. Pretty big, $13.50 for a ductless by hitting 17 SEER 9.5. And then for regular ducted heat pumps, there's no HSPF requirement, just SEER, 16 and 18, $1,400, $2,000. I think part of what they're doing there, other than trying to motivate people to go to heat pumps for all kinds of, electrification reasons, is they realize there's these tax credits coming next year. And if they can kind of make you do some, people are going to wait for the tax credit, right? And we'll wait a couple more months. This kind of says, just do it now, get your money now, get the big dollar amounts now. And yeah, you didn't get the big tax credit, you get the small tax credit, but you got the big rebate, right? That's kind of the idea with this. All right. Based on that, all right, what are the different ways you can claim a ComEd rebate? Your choices are standard application, midstream distributor, or both, but it depends on the kind of equipment that you have. This should be a relatively softball question. And then I'll immediately launch question number 6 right after this, and we'll just knock it out. And I apologize for being 16 minutes over. And if anybody has more questions or anything, I can continue answering those kind of things. So 68% of people answered. We'll give it another 10 seconds. All right, 3, 2, 1. All right, 92% of you got it correct. There are both standard, fill out the application, turn it in, or midstream, have your distributor claim everything for you on the back end, options, and it depends on the kind of stuff you're working with. Like chillers, it's only standard. Rooftop units, it could be either or. Residential, midstream, right? It just depends. Last question for those that need PDHs. It's super easy question. Do you need a PDH certificate? Yes, it is the same as question 1. Yes, it is a softball question. So everyone should be able to knock that out super, super easy. And I'll give that, 5 more seconds here. Nick is asking back on the residential duct leakage testing question. A follow-up question. So we just need to test the new duct or the whole system? So if you added ductwork, you would need to test the new ductwork. It's kind of difficult to do just the new piece of ductwork. So testing the whole system might be easier. I guess it probably depends on how much you added. But technically, you just have to test what you added. But if you change a bunch of stuff, that makes it harder to do that. And I would imagine some inspectors are a little different on how they interpret that. And quite honestly, if anybody's like, so a lot of times you install a new furnace, you might put a new return drop in there, like the piece of ductwork right next to the furnace. I haven't seen one village at all say anything about, well, you need to test that piece of ductwork. Like, it's like, really? Come on. So there's usually some reasonableness to that. It's intended for obviously new construction and like major projects, major, rehab projects. But technically there's no real exception for anything. So if you just like put in 1 foot of extra ductwork, you technically would have to test it. All right, so that's all the poll questions. Like I said, I will grade all of those this week, and we'll get your certificates mailed out next week. Give me at least a week before you hound me, because there's an insane amount of people on this webinar today. So give me a little time on that. For anybody that wants to stick around, you're certainly welcome to do so. I think I got a couple more slides I can kind of highlight on here for you, just so you know things that are going on. I'll blow through them real quick. If you want to log off, that's totally fine. No problem in that regard. We mentioned the residential rebates changing for the heat pumps. These ones, AC heat pump and ductless heat pump, are processed as a midstream rebate through your distributor. These other ones are not done that way currently. They are processed old school application. That might change next year. It'd be great if SmartStats can go on to the application with the AC. That would be a pretty logical thing, because those are always done together. And then if they just keep these specialty things like geothermal on its own bucket, okay, fine. But at least get SmartStats over on the other bucket. But these rebates are available to you as well. So right now you're doing 2 rebate applications, one with your distributor, one with ComEd, to get the maximum amount of money there. For people that are in the Peoples and North Shore gas area, nothing has really changed since the first of the year. They did add some stuff for this year, so just to make sure you're aware of it. If you do plumbing stuff with hot water recirc systems in temporary living, hotel type living. There are some rebates for that. There are rebates for hotels and motels and healthcare facilities for water reduction through low flow faucets and aerators and showers and stuff. There are some changes for 2022 that changed back at the first of the year. So additional rebates for tune-ups were added. Some of the caps bumped up. It's all good news stuff. Less paperwork on smart stats. Steam trap testing, everyone's favorite. There was some changes there. From dollar amount standpoint, if you're doing big stuff, boilers, $1.25 per MBH input to go to higher efficiency boilers, which means 88%, which basically means condensing boilers, because there's no 88% non-condensing boilers. So if you put a condensing boiler in, $1.25 per MBH input for each of those boilers that you put in. On the steam side, you got to get up to 81 or 82%, depending on the size, and you can get $1 for each one of the MBH inputs there. If you're doing furnaces and rooftops and boilers, you can do tune-ups as a contractor and get paid some money to help do tune-ups to get things operating back to the way they were supposed to be operating. And then on the residential side, same kind of rebates we've had for a while, 95% furnaces, hot water boilers, smart thermostats. So you can get the $100 from ComEd and the $25 from Peoples and North Shore if you in fact have both of those utilities. So a few changes happened there back at the first of this current year. Duct sealing is still rebatable up to $400. You can seal the whole house. You can insulate. All those are rebatable type things. On the Nitecore side, I can't even read my own chart there. It's a bad screenshot, Ryan. Nothing changed basically from 2021 to 2022. So if you're already involved in the program, you know what the deal is. If you're not involved, you probably should get involved. There are rebates for condensing boilers, rebates for furnaces commercially, infrared tube heaters, as actually any infrared heater, not just tube heaters, condensing unit heaters, which are not super common, but they're out there. We have some like the Sterling one that we've been using on projects with some of you guys. Programmable thermostats are rebatable on there. And then some of the more field type things like adding demand control ventilation, insulating pipes, all that stuff, same as prior years, no changes there. Boiler tune-ups, same as prior years. There's a replacement for radiators. I don't know if anyone's actually doing this. Radiator replacement is super rare, but that's on there. Descaling boilers is on there now. Those are newer items. Some changes to things that affect the heating load, even though it's not HVAC guys, like insulating or shutting of the garage door systems, and then piping insulation. You can obviously do anything custom on any of these utilities. ComEd, Nitecore, Peoples, North Shore, Focus on Energy, NIPSCO, they all have custom. So if you don't see something in the regular program, you could probably do it as a custom type thing. It doesn't make sense for little tiny projects, but for big stuff, it makes a lot of sense. Residentially on Nitecore, all the same rebates we've had in the past carried over from 2021 to 2022. And then they added tankless water heaters. That is new. And combi boilers are new on there as well. So if you do that kind of work, you didn't know about those changes, you should be getting those rebates for your customers. And then no change on the smart stats. So just like Peoples and North Shore, Nitecore has a $25 smart stat rebate. You could double dip that with the money from ComEd. The other nice thing about Nitecore compared to ComEd is they are more accepting of some of these communicating stats that we use on a lot of our high-end projects, whereas ComEd does not accept those. They only accept like regular two-stage stats. So a little difference there. Duct sealing from Nitecore as well, attic sealing, insulation, all that stuff is rebatable. We did a question 5 and 6. Okay, that was everything. Oh my gosh, only 23 minutes too long. Not bad. See what other questions I missed from anyone who's still hanging with me. Do we have to be a partner with Nitecore and ComEd to receive rebates for our customers? Kind of. You don't have to for any of the gas utilities in Illinois. I went too far. For ComEd, commercial especially, I skipped this slide. You need to be part of Illinois Commerce Commission as an electrical efficiency installer in order for them to be able to give you rebates. So any contractor doing the work Technically it applies to residential as well, but there's a dollar amount threshold. And because of the dollar amount threshold, you usually it doesn't come up. But commercially, you definitely should get approved by ICC. And then residentially, it wouldn't be the worst thing in the world. So there's a database, you go in there and search and see who's on there. There's the link to see if you're on there or not. If you previously got certified, because this has been going on for like 2 or 3 years to ComEd, if you previously got your ICC certification from the state, you should definitely continue to maintain it, because if you let it lapse and then want to try to reinstate it, you're paying penalties from the time you let it lapse to the time you try to reinstate it. And that's not a financially good idea. So it's only like, I think $100 annual renewal or something like that, something really small. So once you got it done in the paperwork, you should just, keep giving your money to the state and pay your fee and keep moving on. Because you're gonna, as long as you do one project a year, you're already kind of ahead, But other than that, there's no partner really required for most rebates. The other time you might have to be a quote unquote partner of something would be some of these ones. So if you're doing duct sealing, or if you're doing geo with ComEd, and then with the gas utilities, all the gas utilities, Nicor, Peoples, North Shore, if you're doing these type of rebates, air sealing, duct sealing, you need to be set up with them. Rick Hild does this for Nicor, Peoples, and North Shore and ComEd, like all. So you just set up one time with Rick, and you're good for all of those programs, those weatherization type things. So air sealing, duct sealing, which some of you guys do, and insulation projects. You need to be set up with Franklin Energy through Rick to be able to offer it through the 3 gas utilities in Illinois, as well as ComEd. And then if you are doing ComEd geothermal, there's a separate thing you need to do with the Ground Source Heat Pump Alliance to get set up. What else? Other questions? Several people asked for copies of the slides. Yes, I said I would post them online and then email you guys a link to them tomorrow so you can download them if you want them. Other questions? All right, well, I appreciate you guys sticking it out with me. I know it's a crap load of information changing, but at least maybe you know a little bit about it, and then you can look at the slides later and find out where you need to dig more. Half the stuff doesn't apply to half of you, right? If you don't do commercially, then you don't care about half the stuff I said, and vice versa. But there is a bunch of stuff that applies to people. So hopefully you got an idea what to do. And I appreciate you guys joining me, and I will, in fact, see you next time.